Section 5. Saving the game and communicating with objects. Commands with references, SendMsg, and UnityEvents. Messages can be sent in 3 different ways within Unity. The way you choose to send them depends on how strongly coupled you want the objects to be. Objects which are strongly coupled can be formally checked for correctness, but they are less flexible to use. In exchange for making multiple combinations, the programmer may be unable to anticipate how loosely coupled objects will behave, so they are more error-prone. All methods of sending messages use what is called the command pattern. The command pattern is very simple. Given a target object and a message, send that message to the target object. The simplest way to achieve the command pattern is direct invocation, but Unity provides 2 other methods called SendMsg and UnityEvents. In Unity, there is some flexibility about what parameters to send with a message, but the programmer must always decide what type of object will be sent. To send a message, we need a receiver, so we're going to start by defining one. The receiver will be capable of receiving 3 messages. Message 1 echoes the message it receives. Message 2 also echoes the message it receives. Set color will change the color of the primary material of the object it is attached to. Since just logging text all the time is boring, we're going to use this to show how one object can affect another object in large and drastic ways. Now to define senders. The most obvious way to communicate between objects is a direct invocation. In a direct invocation, the type of the target object matters. Restricting the type of the possible objects of the target guarantees that the responding object has implemented the command. This is also the fastest way to send a message, because the runtime does not have to use reflection to figure out which method to call. The second type is a monobehavior.sendMsg. SendMsg will call every script on the target game object with the given message. Monobehavior also provides SendMsg upward and broadcast message, but do not use these, as these will send messages to the parents and children respectively. It is better to send to a single object and then have that object relay messages to specific related objects somewhere down the line. A send message may optionally require a receiver. If it does not require a receiver, then misspelling the target function name will not be fatal. If a receiver is required, then sending a message to a function that does not exist will cause an exception to occur. To make the messenger appear as a nested drawer in the inspector, we have applied the system serializable attribute to the class. We need 4 important fields: a list of targets to which we can send the message, the name of the message that will be sent, whether or not we require a receiver, and any arguments that will be sent with the message. We're also going to create a function called send that will actually send the message. If there is no argument to the message, then this class itself will be used as the argument. To send the message, we will iterate through all of the targets and call SendMsg on each of them individually. To actually use the SendMsg, we will define an array of SendMsg objects. Defining an array of messenger objects will cause several messenger objects to appear as an array in the inspector. I have assigned 2 messages. Message 1 and message 2 will be sent to the test receiver we defined earlier. The third newest type of message is the Unity event. A Unity event is a hybrid of the previous 2 methodologies. Instead of specifying the message as a string, as was the case with the previous object, we instead define a message with a specific target in mind. Here we see we can target the test message receiver and send one of the specific messages we defined earlier. I'm going to select message 1. Note the name of the 2 Unity events defined here. The first is called onCKey. The next is called onDKey. Unity events can also perform some predefined actions. For example, to the onCKey event I've added meshRender.enabled and selected a value of false. This means that when this event fires, the mesh render of the target object will be disabled. The target object is the sender of the message, which in our scene is a cube. Within the code file, these 2 events are defined. onCKey is simply a Unity event. In this form, the event does not take any argument. The second event, onDKey, is a color event. The color event is a subclass of a Unity event with type color that I defined. In order for an event with a typed parameter to show up in the inspector, it is necessary to subclass the Unity event into your own class. Unity cannot directly serialize a templated object. So in order to make the Unity event show up in the inspector, we have to subclass the Unity event with type color into the color event. Let's take a look at how the events will be fired. In the update function, I am simply scanning various key codes. Direct invocation will happen when the A key is held. The SendMsg messengers will have their messages sent when the B key is held. OnC key will fire when the C key is held, and the color event on D key will fire when the D key is held. Note that the direct send color invocation uses a color value. This is defined in the inspector. Notice also that on D key takes a value. I have hard-coded this to white. We can now run the game and look at the effects of holding the A, B, C, and D keys. Holding the A key will change the color of the plane within the scene. The plane's color is changed to magenta because this is the value of the color we set in the inspector, and the receiver object is the target plane. Now let's press the B key. Pressing the B key caused the receiver object to receive messages 1 and 2. If we press the C key, we'll get message 1 again. The sending object's renderer is also disabled, so the cube vanishes. Finally, pressing the D key will change the plane's color back to white.